Hey guys, so we're going to take a look at solving rational inequalities. So we're going to go through 4 different examples, and here's our first one. So the first thing you want to do is make sure that you have a rational expression, single rational expression, and then 0 on the other side. So we have a single rational expression here, and then it's greater than or equal to 0. So that part's already done for us, okay? Now, I want to identify if I'm looking for this expression to be positive or negative. So think of it like the rational expression, you can just call that your function. And you want to know, should it be positive or negative based on the inequality sign. In order for this to be greater than or equal to 0, it needs to be positive. So we want positives in this particular problem. Okay? We want positive values when we go to test later on. Okay? That's an important thing for you to be able to identify. And you should do that right from the get-go, right at the very beginning when you have the function and the 0. Identify, do you want positives out of this inequality or do you want negatives? So in this case, we want positives because we want the function to be bigger than or equal to 0. Okay. Now we want to start thinking about, well, what x values would be the breaking points for our intervals? And to figure that out, we want to take a look at what are the domain restrictions. And we're going to mark those on a number line using open circles. And then we're going to look at what makes the numerator equal to 0, because that's technically an x-intercept when we get to a graph. And that's also a place where the entire expression would come out to 0. Okay, so we're going to start with domain restrictions. Domain restrictions, okay? You can abbreviate that dr if you want. All right, and if we look at the denominator equal to 0, our domain restriction is x is 4. That's going to be an open circle. All domain restrictions are open circles, okay? You can even write the domain restriction as x cannot equal 4 if you prefer, all right? To remind yourself that you cannot equal it, so it's an open circle. Then we want to look at the numerator equal to 0. Okay? So we want to figure out what number will make the numerator of our expression equal 0. So if I do x plus 6 equals 0, I get x equals negative 6. And then you have to decide with the numerator part, which are technically x-intercepts, are they equal to or not equal to? Are they open circles or closed circles? And because there's an equal to here, the numerator part can be a closed circle instead. Okay, so we're going to have a closed circle at x equals negative 6. All right, we are now ready to start making our number line. So over here, I'm going to draw myself a number line and mark my 2 x values. Okay, so we have negative 6 and positive 4. We said that negative 6 is a closed circle. You can draw it above the number line or right on the number line. So I could also put it right here, right there. Okay. At x equals 4, it has to be an open circle because that was a domain restriction. So this number line is broken into 3 segments, one on the left, one in the middle, one on the right. So I need to test a value from each interval to see if it gives me a positive value or a negative value. And keep in mind, we said that we wanted positive values out of this problem, okay? So let's pick a number from the first interval on the left. So I'm going to go right here and say, well, that number could be x equals, say, negative 7. Okay? So if I go with x equals negative 7, I want to plug it into the original expression. So I'm going to do negative 7 plus 6 over negative 7 minus 4. So that gives me negative 1 over negative 11, which is a positive value. Keep in mind, the actual number itself, not important. I just need to know, is that number a positive number or a negative number? Okay? And we said back here that we wanted positives, so that means if x equals negative 7 is positive, all the numbers in that interval will work. So this came out to a positive, which means we want to keep that as a solution. Okay? So all the numbers smaller than negative 6 will work, including negative 6. Okay, now I want to test another number. So now I'm going to go to my middle. All right. So pick a number between negative 6 and 4. What's the easiest number to use? Let's go with 0. So I'm going to plug in x equals 0. So I have 0 plus 6 over 0 minus 4. That gives me 6 over negative 4. That is a negative result. We don't want negatives, we want positives. So these numbers do not work. So I will not draw a line segment there because none of those numbers in the middle are going to work in this inequality. Okay, one more. We need to test on the right, okay? So now I need to test a number here. So something bigger than 4. So I'm just going to go ahead and use 5. So I'm going to try x equals 5 and see if that works. So I'm going to do 5 plus 6 over 5 minus 4. That's 11 over 1. That is a positive value. Okay, and again, we want positive, so we're going to keep that. Positive works, so we draw everything over there. Okay, so our number line, the numbers that worked were everything smaller than or equal to -6 and then bigger than 4. So we need to write out the interval notation that goes with that. Okay, so interval notation, remember, is the brackets and the parentheses. Bracket goes wherever you have an equal to, so this will be a bracket right here, okay? And then an open circle is a parenthesis, like that. And then infinities are always parentheses because you can't actually equal infinity. It's not technically a number, it just means we keep going on and on, okay? So for this interval on the left, we're starting at negative infinity, and then we're ending when we get to -6. We can include the -6, so there's a bracket there. We have a separate interval, so we write our union sign. And then we start at x equals 4 with a parenthesis because I can't equal 4. And then I go on to positive infinity. So this is the solution set to the original inequality. Okay? Let me know if you have any questions.